Hi, this is Dan. This is the solutions video for the Chapter 4 through 6 exam, Fall 2013. There was actually 43 points in this exam, and the way I kind of curved it was I just made it out of 50. So if you missed one, if you got 42 out of 43, you really got 49 out of 50. So that kind of helped the people who did worse a little more. But for those of you that studied, you did great. For those of you that didn't study, not as well. So the first one here is pretty straightforward. Which one cannot be probability? Probability is between 0 and 1. B is -1, so that can't be a probability. On 2 here, if a certain town has 25% that commute, how many don't? It'd be 75%. And the odds is success over failure. So if 25 out of 100 are success, 25 are success, 75 are failure, so it's a 1 to 3 ratio. What would be the probability of selecting two people in a row that do? So if it's 25% and 25%, multiply those, so you get about a 6%, 6.25% chance. And on the next one, what's the probability of getting exactly 2 out of 5? So it's a binomial. So it's 5, choose 2, 2 successes, 0.25 to the second, and then 3 that do not, which is 75% chance, and you want 3 of those. So it's about a 26% chance that that scenario would happen. On 3, 79% of adults, what's the probability that if you randomly pick 4 in a row, all do? So on insurance and insurance and insurance and insurance, multiply all of those is where you get this 0.79 to the fourth, which is about 39% chance. And what's the probability exactly 3 out of 4? It's similar to the last one, so 4C3, 0.79 is the probability of success. You want 3 of those, 0.21, which is 1 minus 0.79. That's the probability of failure. You just want 1 of those, so about a 41% chance of that scenario. And then 4, this is conditional probability again, but if we've got 2 defective and 8 good, essentially, so there's out of 10, 2 are bad. So what's the probability of getting 2 good ones in a row? So 8 out of 10 are good, so that's a probability of a good one. And then we're going to put that back in the pool, draw it again, it's still 8 out of 10, which is about a 64% chance. And then redo this without replacement, which means 8 out of 10, again, is the first selection, but since there's only 9 left, and only 7 of them are good because we pulled 1 out, so it's 7 out of 10, 7 out of 9, it goes down to 62% chance. Number 5 is a table that you're given. I put the totals here. You'd want to do that, and it says what's the probability out of 255 that a person's over 40. So there they are, over 40, 85 out of 255. Pretty straightforward. Success over total. What's the probability of getting someone under 21 or root beer? So under 21 is 85. Root beer is 75, but it's the probability of A union B, which means you need to subtract the ones that we counted twice, and these 25 right here were counted twice, which gives us 135 out of 255, or a 53% chance. And then probability that someone's over 40 given they like lemon lime. So look at the ones that are both over 40 and lemon lime. There's 35 of them. And now we're just going to compare it to the ones given they like lemon lime. So we only look at the lemon lime category. So 35 out of 85. Number 6, we want to find the probability that among 7, at least 1 gets a job. So that would be 1 or 2 or 3 or 4 or 5 or 6. So the probability that, instead of finding all of those and adding them up, an easier way to find that is to take 1, which is the probability of everything, minus the opposite. So what's the opposite of at least 1 getting a job? That means nobody gets a job. So what's the probability that all 7 do not have jobs? Well, if it's a 55% chance that they do, it's a 45% chance that they don't. And I want that to happen 7 times in a row. So I want no job and no job and no job and no job 7 times. So that's going to be 1 minus the probability of the opposite, which is 0.45 to the 7th, which means there's about a 99% chance that you'll find at least 1 person that has a job. 7 is the expected value formula. So you sum x times the probability of x, so you just multiply these straight across. So 0 times the probability, all those, and then you add them all up. So the average houses sold would be 3.6 out of this distribution. On 8, it's expected value with reference to the policyholder. I only took a half point off if you didn't have the sign correct, but pretty much you find what's the probability that they get paid, the probability that or their whoever their policyholder is gets paid. So you get $140,000. The probability of that is 0.0006, which is if they live is 0.994, the probability they die was 0.006306. And then minus the premium cost, which is $165, which gives you a negative $81. So for the policyholder, it's a negative 81 bucks. And if you didn't have the sign, it was just a half point. On 9, it says they're going to accept the whole thing if there's fewer than 3 defects. So if there's 0 defects, 1 defect, or 2 defects, we're good to go. So you have to find the probability of all 3 of those and add them up. So here's 22 C0. That means they're all good. Or I'm sorry. Yeah, essentially this is all good, which means we have 0 bad and 22 good. So that's really 20. That's 0.93 to the 22nd. This is the one to calculate for 1 being bad. There's 22 ways that could happen. That's what takes care of that. 0.71 bad one, the rest good. And this one is 2 bad, the rest good. And you add those up and you get about an 80% chance. On 10, you just got to look up 0.92 in your z-table, and you get 0.8212. That's the area to the left. That's all of this. And then look up negative 0.92, and you get 0.1788, which is the area to the left. So their difference is the area of the shaded, which is about a 64%. On 11, you got to look up the z-score for the 96th percentile, and that's about 1.75 standard deviations above the mean. So we know the z-score is 1.75. We don't know what score it is. We know the average is 0 and the standard deviation is 1. So this is just the z-score formula. A lot of you didn't even need that. You're like, oh, it's just 1.75 standard deviation. It's 1.75 standard deviations. That's 1.75 times 1. So it's 1.75 degrees Celsius is the 94th percentile. On 12, just straight z-score 1, find the percentage that earn less than 525. Find the z-score, it's 0.78. What's interesting is if you look up 0.78 on your z-table, that's almost identical to the area to the left. So the probability is about 78% as well. And then what's probably the average of 10 teachers? This is the central limit theorem, which means we add this part right here, this divide by the square root of 10. And so that's 2.45. That's much farther to the right. If you look that up, it's 0.9929. So much more probable that the average for 10 teachers will be less than 525. On 13, we know the we want to find which score separates the top 59 from the bottom 41. So right here, the bottom 41, if you look that up, that z-score is negative 0.23. So it's not a long ways away from the average. So we know the z-score, we know the average, and we know the standard deviation. We just need to solve for what score that is. So we'll multiply both sides times 7.6, then add the 37.6 over. So a score of 35.3 would be the kind of the cutoff for the 41st percentile. On 14, this is a pretty classic z-score one. You calculate the z-score for the first exam, and it's 1.43 standard deviations above the mean, which you didn't have to. It's a 92nd percentile kind of thing. But then you need that 1.43 for the second one, because you want to, what's the equivalent on the second exam? So we know z, we know the average, we know the standard deviation. We solve for the score that gives us the same ranking. So multiply by 10.8 and then add 71, and we get 86.43 is the equivalent of a 29 on this exam, and 86.43 is the equivalent on this exam. And the last one, it's pretty much straightforward. Find the probability that their test score is greater than 0.78. Actually, that should be shaded the other way. So the z is right there. It's 0.625 standard deviations. You look that up. Find the area to the right, which is 1 minus that. So it's 1 minus this 0.7324. So it's about a 26% chance that they'll do better than 78. And then what's probably that the average for a group of 24 would be better than that. If you do that, you have to divide by the square root of 24, which gives you 3 standard deviations, 3.06. And the area to the right of that is very small, 1 minus 0.9989, so about 0.0011% chance that it's greater than, the class average would be greater than 78. So again, pretty straightforward. There was quite a few A's, but there was some that weren't too. So hope this test helps you get ready for the final or for a test in another semester.